So what I'm going to cover in this video is just to give you some extra practice with drawing carbon molecules, because we will be using a lot of carbon molecules when we get into organic chemistry. So this is going to be useful for going forward in this particular topic. So I'm going to draw a C3H6. So again, there's many different ways of approaching it. You could do it the way I taught you, which is to count up the valence electrons. So I have 4 valence electrons for carbon, and I have 3 of them. And then I have 6 hydrogens, and they have 1 electron apiece. So that's 12 plus 6 is giving me 18 electrons. So if I divide that by 2, I have 9 lines in my structure, okay? It's a good rule of thumb to kind of do it. Or you could kind of approach it this way. The carbons are always going to be what I call your backbone. So you're going to draw the carbons all attached to each other. Start there. That's your backbone to the molecule. Then you go, okay, well, carbon needs 4 lines around it in order to make it a complete octet. So if I were to just draw the lines here for where I would put hydrogens, okay, I'd put hydrogens on each one of these lines, okay. If I count up my lines, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have too many lines in my structure. So anytime I go over that, I'm going to have to do what I call double bonds. And if double bonds don't work, then do triple bonds. So I'm going to draw some kind of double bond in this molecule. So again, the carbons are the backbone. Then this carbon here has only 2 hydrogens attached. And this carbon in the middle is going to have only 1 hydrogen attached. And then this one on the end is going to have 3 hydrogens attached. So again, when you're drawing the structure, start off, again, pencils are wonderful, and see how many lines you need to draw. And then if you have too many lines, go down to double bonds. If 1 double bond doesn't work, then try 2 double bonds. If that doesn't work, try a triple bond, so on and so forth. Now, for the drawing of the molecules, I'm also going to go over the shapes and also the polarity. So I have to label my carbon molecules 1, 2, and 3. It doesn't matter where you start, just as long as I know what carbon is what. And you're going to look at each carbon individually. Okay, so carbon 1 that I've labeled 1 here has 1, 2, 3 locations of where bonds are. The double bond doesn't make any difference. It's still a location. So C1 is going to be what we call a trigonal planar, because it has 3 locations and no lone pairs. If I look at C2, it also has 3 locations, 1, 2, and 3, where bonds are formed. So C2 is also going to be a trigonal planar. Pretty typical for a double bond to be a trigonal planar. And then C3 has 1, 2, 3, 4 lines around it. So that's going to be a tetrahedral. Now, what's interesting about the carbon bonds, the carbon molecules that we'll be drawing with the carbons and hydrogens, they are going to be typically these types of shapes. Well, these types of shapes tend to be nonpolar. And so organic molecules, when we start to get into other things, they will have some polarity to them. But for right now, the carbons and hydrogens that I give you are going to be nonpolar. So see if you could draw C3H4, okay, C3H4. So pause the video, and then when you come back, you're going to see me work it. So pause the video. So again, I would have 3 times 4 electrons plus I have 4 times 1 electron. So I have 12 plus 4 is 16. So I divide that by 2, that is 8 lines in my structure, 8 lines in my structure. So again, start with the carbon as the backbone. Start with the carbon, the backbone. And now I see only have 4 hydrogens here. So there's no way I could fill this completely up with all single bonds. So I probably have some kind of double bonds or triple bonds in this structure. I'm going to try a triple bond and just see where it gets me. So this hydrogen goes on this carbon. The carbon in the middle can't have any hydrogens because it already has 4 lines around it. And then finally, this carbon on the end is going to have 3 hydrogens. So this is a legitimate structure for this. Could I draw it a different way? Well, I could also draw 2 double bonds. The carbon in the middle would not have any more hydrogens, but these 2 on the end could have 2 hydrogens, and so you would have C3H4. That would work as well. So when you're doing these, you're going to label each carbon, okay, and then tell me the shape. Okay, so C1 and C2, because you have a triple bond, is really going to force that into a linear shape. You're really going to have no other option there. And then C3, the way I drew it, is a tetrahedral. I go down to this example, which was the 2 double bonds. C1 and C3 are going to be trigonal planars. And then C2 in the middle here, it's going to force it into a linear shape. Okay, now all of these are nonpolar because again, these are nonpolar shapes and it's just carbons and hydrogens. So let's try one more. So draw C5H8, C5H8. Pause the recording and see if you could draw it. So here's 2 different ways I drew it. And again, please note that for these, there could be multiple ways that you draw them. They're called isomers of each other. So this first one, I did 2 double bonds. Where you put the double bonds, again, is purely arbitrary. So I put it here and here. So then it makes the 1, 2, 3, and 4 all a trigonal planar shape, and then the 5 on the end is going to be a tetrahedral. So again, depending upon where you put that double bond. Again, if you put 2 double bonds next to each other, it's probably going to make a carbon a linear shape. If I put a triple bond somewhere in the structure, that would also work. Wherever the triple bond is going to make it linear, and then the rest of them are going to be a tetrahedral. And again, all of these are nonpolar molecules because these are nonpolar shapes. So that gives you at least a little bit extra practice on carbon molecules.